Okay, so now we get to talk about removable discontinuity. So here's a function, and we're going to look at this one. I'll just leave it that way. Okay, so the numerator factors, x plus 1, x minus 1, it's the difference of squares. The denominator also factors, x minus 3 and x plus 1. Okay? So we know something about the domain. In the domain, we can't have x being 3 and we can't have x being negative 1. That is true. Now, I didn't write it in interval notation, but they don't ask for the domain right here. But just note to yourself, hey, x can't be 3 and x can't be negative 1. But what happens now, the x plus 1 cancels with the x plus 1. The function simplifies. And so now we have x minus 1 over x minus 3. If we were trying to graph it, this is what we would graph. And it turns out that this is a reciprocal function. Okay, so it's going to look like a reciprocal function. How do you graph that? You could find ordered pairs, and there's other things you can do. And we'll get to that. But for here, we're just going to talk about what that removable discontinuity means. Okay. So I'm going to look at the graph, and it turns out that there's a horizontal asymptote at 1, okay? So that's not a good place to put the 1, but there's a horizontal asymptote. There's a vertical asymptote from right here. Oh, shoot. The vertical asymptote comes from there. Now, you might be thinking, oh, that horizontal asymptote came from the numerator. Not exactly. We'll talk about that later. So that's just kind of a fluke on this problem. But the vertical asymptote comes from the denominator, x minus 3. So we have a vertical asymptote at x equals 3. Okay? We knew x couldn't be 3, but there's actually a vertical asymptote there. So 1, 2, 3. There's a vertical asymptote here. Okay? Now the graph, it looks like the reciprocal function, kind of, so it goes like this. It's got a little bit of a stretch to it. But what happens at negative 1? Remember, I can't have x be negative 1. This is the removable discontinuity. I don't even know if continuity there. Well, anyway. So that's how it's being described. That's what they're calling it, a removable discontinuity. So there's a function here in the bottom part. You know, it looks like the reciprocal function, and it's shifted like 3 units to the right and 1 unit up. But right at negative 1, there's going to be a hole in the graph. Okay? So it's not defined at negative 1. The graph is going to continue like it normally would for a reciprocal function. This one happens to be a reciprocal function. But there's the hole in the graph, and that's why it's removed, okay? And it doesn't, and now our graph is not continuous. Remember, polynomial functions that we worked on, those are smooth continuous curves, but rational functions are not smooth continuous curves, okay? So there's this spot where you kind of have to jump over that hole in the graph. And that hole exists because we can't have x be negative 1. So our function's not defined if x is at negative 1. And you don't see it because you simplified that function, right? And so that factor got canceled out. But you still have to remove it from the domain, and so it puts a hole in the graph. Okay? So that's when they talked about removable discontinuity, that's what they're talking about, a hole in the graph.